Hello everyone. In this video I would like to show you how to find the greatest common factor, also known as the GCF. So in this video I have three examples that I would like to work on. So in this first example I'm wanting to find the GCF between the two numbers 28 and 12. So when I'm solving this I always start with the largest number of the two, which in this case is 28, and then 12. And I put a colon next to both of the numbers. So all finding the greatest common factor is finding the largest number that two or more numbers have in common. So we always start with 1 in whatever that number is. So if you're finding the GCF of 15, you're starting with 1 and 15. So we put 1 first and we're putting 28 to the far right. You want to leave a nice little gap between the two numbers is because you're going to be putting numbers and filling those gaps. So basically what we're doing is we're going to go up the number line 1 through 9 and see if and how many times can a number go into 28. So we already have 1, so then we move up the number line like I said and we start with 2. So we put a comma 2, or well, first we have to see if 2 goes into 28. So we do that. Well, for one, you should know that 2 goes into any even number. So 28 is obviously an even number, so we know 2 should go into 28. But if we don't know that, we can always use our calculator, assuming that you can use your calculator. So we type whatever the number that you're wanting to find in the calculator first, 28, and you divide it by the number that you're going up the number line with. So in this case it would be 2. So we do 28 divided by 2, and we get 14. So 2 goes into 28 14 times. And then we're going to go up to 3. We're going to say 28 divided by 3. So you see in this output we get a decimal. We get 9.3333 and so on and so forth. Well, if we get a decimal point, that means that number doesn't go into whatever number we're trying to get it to go in evenly. So 3 will not work. So we move on. Let's go to 28 divided by 4. We get 7. So we put comma 4, 7. Alright, let's try 5. We get 5.6. Again, there's a decimal, so it doesn't go into that number evenly. Also, 5, a little side note, 5 goes into any number that ends in 0 or 5. So 28 doesn't end in 0 or 5, so we know 5 can't go into it. So let's try 6. Another decimal, it doesn't go in there. And we know 7 does. So since we're getting to, when we're going up the number line, we're getting to a number we already know goes into that number, we can pretty much stop there because we can't go any further. We know 8 can't. We know 9 can't. But just for practice purposes, I will show you that they do not go into 28. So 28 divided by 8, decimal. 28 divided by 9, decimal. Alright, well let's move on to 12. See the factors of 12. So again, we start with 1 in that number. Alright, so we're going to go up the number line. We're going to say 2. And since I'm assuming that you can use a calculator, I'm just going to go ahead and write these numbers. 2 goes into 12 times, or 2 goes into 12 6 times. So we put 6 on the right hand side. We ask ourselves, can 3 go into 12? We know it can. It goes into 12 4 times. We know 5 can't because 12 doesn't end in a 0 or a 5. We know 6 can because we already have that in our little GCF line. So once we start repeating numbers, we know we can stop. So for example, if we asked ourselves, can 4 go into 12? We know it can 3 times, so we would be repeating ourselves. So it's pretty much redundant um, to start repeating the numbers. So like I said, we can stop there. So then we need to figure out what's the largest number these two numbers have in common. They have 1 in common, they have 2 in common, they have 4 in common. So which one's the largest one? Well, you should know that the largest number that they have in common is 4, because 4 is the largest number that they have in common. Alright, and that's it. So we just write GCF. Well, that looks terrible. GCF equals 4. And that's it. Alright, let's go to number 2. So we're trying to find the GCF of 90 and 30. Well, like I said, we always start with, well, I always start with the largest number, 90 and 30. And again, I'm just going to go through the numbers and go ahead and tell you the answers. But if you have to, just rewind back to the part on 28 where I'll show you how to put it in the calculator. Alright, so we have 90, and we're trying to find the factors of 90. So we always start with 1 and 90. This is a larger number, so I'm going to give a big gap. 2 goes into 90 45 times. 3 goes into 90 30 times. Ooh, let's see if 4 can go into 90. I don't believe so. Nope. We know 5 can. 5 goes into 90 18 times. So 5, 18, 6. 6 might go into 90. Well, I know it does. But how many times? 15. Cool. So 6, 15. What about 7? I doubt 7 goes into 90. Nope. What about 8? Nope. We know 9 goes into 90. But how many times? If you know your times tables, you should know that 9 goes into 90 10 times. There we go. So 9 and 10. So I told you at the beginning of the video that we always see, we always go through the number line 1 through 9, and we stop at 9. There are times you have to go past 9, but I doubt your teacher makes you do that. So let's go ahead and do 30. So we're starting with 1 and 30. 2 goes into 30 15 times. 3 goes into 30 10 times. 4 can't go into 30. 5 goes into 30 6 times. 7 can't, 8 can't, and 9 can't. So we can stop there. Here's the fun part. I gotta figure out what's the largest number that both 90 and 30 have in common. So they have 1, 2, 3, 5, 6, 10, 15, 30 in common. And if you said 30 was the GCF, you would be correct. Because 30 is the largest number that both 90 and 30 have in common. So we write GCF equals 30. Alright, that's it for that one. Alright, so let's move on to number 3. Number 3 is interesting because we're given a number and a variable at the same time. So what I like to do on this problem is I like to break it down into components. I like to find out what's the GCF between my numbers first. And then after that, I like to see what the GCF between my variables are. And I know you're thinking that's going to be super hard, but actually it's easier to find the GCF between variables than it is numbers. So, like I said, let's first go into the finding the GCF between the numbers. So this time we have 3, except unlike last time we had 2. So like I said, we always start with the largest number, 21, 14, and 7. So these are not going to be that hard because they're smaller numbers. So we start with 1 and 21. 2 can't go into 21 because 21 is not an even number. 3 can go into 21 7 times. 4 can't, 5 can't, 6 can't. We know 7 can, so we can stop there. So let's do 14. 1 and 14 we start with. 2 can go into 14 7 times. 3 can't go into 14. 4 can't go into 14. 5 can't. 6 can't. We know 7 can, so we can stop there. And you notice 7 is a prime number, so meaning only 1 in that number can go, or is a factor of that number. So 1 times 7 is 7. We can't do anything else to make any other number go into 7 evenly. So that's why we call it a prime. So 1 and 7 is it. Alright, now we have to figure out what's the largest number between 21, 14, and 7. What's the largest number they have in common? Well, we see it is 7. Awesome. Alright, so we know our GCF is going to have a 7 in it. Alright, but that's not our final answer. Because like I said, we have to find the GCF between the number and the variables. Alright, so I mentioned earlier that finding the GCF between variables is the easiest part, because you pick the variable with the smallest number. So you see, this variable has x to the third power, this has x to the second power, and this has x to the fourth power. So out of the numbers 2, 3, and 4, which is the smallest? Well, if you pick 2, you would be correct. So our GCF will have x squared, or x to the second power. So like I said, all we have to do is pick the one with the smallest number. Now, you're going to have an example, or I'm sure you're going to have an example or a homework problem that might have a number that has, just for example's sake, let's say 10x. Well, that x is understood to be to the first power. So if that x to the first power is the smallest one, then that's going to be your GCF. And another tip is, let's say I had an example. I'm just going to use these numbers from number 3. But let's say I had 7x cubed, 14x squared, and let's say I just had 21. I didn't have x. Well, in this example, we would have a GCF between the numbers. We just done the work for that, so it would be 7. But we wouldn't have a variable in our GCF because there is no variable here. In order to have a GCF, you have to have that number in common with every single number that you're trying to find. And there's not an x in that last number, so therefore we can't use x as our GCF. So that's pretty much it for finding the GCF. In the next video, we will be trying to factor out the GCF. Alright, well, see you next time.